The first objective is, can you state and check the conditions that are necessary for constructing a confidence interval? So as we just saw, the three conditions are, was the sample random, is the 10% condition met, and is the large counts condition met? The first example, Mr. Buckley has a large jar of beads with many different colors, and his class wants to construct a confidence interval for P, the true proportion of red beads in the container, which includes 3,000 beads. The class took a simple random sample of 251 beads that had 107 that were red and 144 that were not red. Check the conditions for constructing a confidence interval for P, see if they are met. So they take a sample, they want to estimate and build an interval to try and capture the true proportion of red beads. So was it a random sample? Is the sample less than 10%? And is the large counts condition met? Yes, it was a random sample. They told us it's a simple random sample, and they took one of 250 from the beads of the container. So yes, the random condition is met. 10% condition. 10% condition is met because 251 is the sample size, which is less than 10% of 3,000, which is how many beads were in the population. Then finally, the large counts condition. Now is when we're going to use the sample and count how many successes and failures there were. In the sample, there were 107 successes, which is more than 10, and there were 144 that were not red, which is also more than 10. So that tells us it will be approximately normal, and we can create a confidence interval for the unknown population proportion. One important thing to make a note of is, now that we don't know P, we're not using P here, we're using P hat, because we do have information about our sample. So we had 107 successes, 144 failures. Next objective, determine the critical value for calculating a confidence interval for a population proportion using a table or technology. Really, I'm just going to have you use technology for each one because it is the best and safest way. To understand what the critical value is, we have to remember what the standard normal curve is. Standard normal curve is any normal distribution that's converted to their z-scores. So the mean of the standard normal curve is 0, standard deviation is 1. We should remember that. The critical value is this value right here, which is part of the margin of error. And it depends on your level of confidence. The reason it depends on your level of confidence all comes from this empirical rule that we've talked about before. If we look at the standard normal curve, we know that 68% of all z-scores are within 1 standard deviation, 95 are within 2, and then 99.7 are within 3. And our critical value comes from this rule here. So as I said previously, it's not actually perfectly 95%, or 95% isn't perfectly within 2 standard deviations. It's within 1.96. And that's why our critical value earlier was 1.96. So to determine your critical value, you have to find the centralized area. So if we want to have a 95% confidence interval, then we have to find the z-score, the negative and the positive z-score that are central for 95%. So that means 2.5% is below this negative z-score and 2.5% is above this positive z-score. So our critical value, we're going to use inverse norm because they've given us an area and they want us to find the z-score. So to calculate a critical value for a 95% confidence interval, we're doing inverse norm where the area is actually 0.025 because that's going to give me the area below the z-score. And this will give me the negative, which will be the same as the positive value. It'll just be, it'll be one's negative, one's positive. So the mean is 0, standard deviation is 1. Let's pull up the calculator and show you how to find this. To get to inverse norm, we do second vars, takes us to distributions, inverse norm. The area we said was 0.025, the mean of 0, standard deviation of 1. So paste, and that will give us negative 1.96 essentially. So this is one way you can find the critical value, which is negative 1 point, or it's 1.96 because for a confidence interval, use the negative and the positive. So all you really need is the value, and you're going to use both the negative and the positive of it. Another way to find this is instead of doing 0.025, you can use the central 95% plus this first to get the positive. And so you could put in the 97.5th percentile and it will give you the same value, just positive. So let me show you that real quick. Again, second vars inverse norm. Now we're going to find the 97.5th percentile. It will give us the same critical value, but now you can see it's positive instead of negative. Either way works. You're going to use both the positive and the negative in a confidence interval. Now pause the video and see if you can find the critical value for a 99% confidence interval. You should have got a critical value of negative or positive 2.576. The reason is we have the central 99% of z-scores, so we're trying to find the 0.005th percentile. So if there's 99 centered, that means there's 1% total left over. Split that in half because it's evenly cut on both sides, and you're left with 0.5%. So inverse norm from 0.005, the mean is 0, standard deviation 1, you should get critical value of 2.576. You also could have done the area to be 0.995 because that would be the positive critical value. Let's look at an example here together. According to a 2016 Pew Research Center report, 73% of American adults have read a book in the previous 12 months. This estimate was based on a random sample of 1,520 American adults. Assume the conditions for inference are met. That's good to know. We don't have to check any of the conditions because they told us. Determine the critical value z-crit for a 90% confidence interval for a proportion. So we're doing the same thing we did previously. If it's a 90% confidence interval, we have a central 90%, which means we're looking for the 5th percentile or the 95th percentile. Our critical value is going to be a critical value of 1.645 for a 90% confidence interval. Again, this would be negative here if you did 5th percentile. It'd be positive here if you did the 95th percentile. So technically mine would be negative. But again, you're using both plus and minus for a confidence interval. Determine a critical value for 80% confidence interval. 80% central means 10% above and 10% below. So find the, that's wrong. Find the 10th percentile. The 10th percentile with a mean of 0, standard deviation of 1, and you'll get a negative 1.282. Or you could have found the 90th percentile, which would give you the positive critical value of positive 1.282. Now they want us to actually construct the 90% confidence interval for the proportion of all Americans who read, all American adults who have read a book in the previous 12 months. So now just write out what a confidence interval formula is. You have your statistic plus or minus the margin of error. So we have all the components here. We took a sample and we had 73% read a book in the previous 12 months. The critical value for a 90% confidence interval, we just found back here, 90th, so 1.645. And then we're going to plug in and calculate the standard error. This would be called the standard error because we're using a sample proportion to estimate a population proportion. So the symbol for standard error of the statistic in this case is p hat. Looks like this. And we had the sample proportion. This is why we use the plus or minus. It doesn't matter if your critical value is negative or positive. You're using both. You're using positive 1.645 and negative 1.645. Then use p hat to estimate the standard error. And so our margin of error will be 0.019. So add it and subtract it from the point estimate to get your confidence interval. Now we have our 90% confidence interval that goes from 0.711 up to 0.749. And you'll see in a second, we'll interpret this. Before we interpret though, it's really important that you follow order of operations here. I see students mess this up all the time where they get the incorrect margin of error and really all they're doing is using their calculator to calculate the values, and you don't want to round until the very, very end. So now to interpret this value, we are 90% confident that the proportion of all adults who have read a book in the previous 12 months is between 0.711 and 0.749. We're 90% confident that the interval from 0.711 to 0.749 captures the true proportion of American adults who have read a book in the previous 12 months.